The world will move from making decisions primarily on cost to making decisions based on a more complete formula of cost plus service plus risk. Today, I'm going to talk about this shift and how you can respond to it in your organization. If you incorporate cost, risk, and service, you'll capture real-world complexity and make better data-driven decisions on your supply chain. A couple of housekeeping items. This is a live event. Our team is manning the chat, so if you have any questions about Simwell, anyLogistix, or technical issues, please don't hesitate to send them via chat when the questions come to your mind. We will respond to these questions live today during the Q&A in the last 10 minutes. Our agenda is to introduce myself and co-host today, and then jump straight into why we are seeing a shift in focus towards identifying and quantifying risk to build resiliency in supply chains. My name is John, managing partner at Simwell. My co-host is Alex Franco, senior supply chain consultant at Simwell. Simwell is a consulting and software distribution company that specializes in simulation, data science, and optimization. We are the anyLogistix partner in North America. We provide anyLogistix software, training, and coaching. So how often have you heard that we're living in interesting times over the last 2 months? Well, I'm sure it's in the dozens. It's not hyperbole. The world is a different place today than it was in February of this year, just 2 months ago. From a supply chain perspective, we now live in a world where supply chain has taken center stage. Supply chain is the topic of the day. What supplies are available? Where are they? Where do we need them? How do we get them there? Whether you're in healthcare, government, grocery, retail, automotive, or any of the other industries trying to build product, you're asking these questions every day. We now live in a world where supply chain has taken center stage, and that's not just because of COVID-19. Supply chain moving into center stage is a change that's been coming on for the last decade. COVID-19 is a catalyst, but it's not the sole reason. In the 50s, the US economy was booming and it was based on local relationships. Naturally, businesses expanded into a national footprint over the 60s and 70s. And then in the 80s and 90s, we started moving to a lowest cost first mindset. Why would you produce locally if you could produce for a fraction of that cost overseas? That's not just true for big companies. If you're a Shark Tank fan, you've seen the sharks attack the small manufacturers that are producing locally when there are low cost alternatives. They know if the companies spend less to produce, they'll have more money to spend on growth. But that lowest cost first mentality adds risk. Now, I'm not saying it's wrong. I'm simply saying that it adds risk. In today's world, we are seeing what risk can mean to a supply chain in the real world, and it's moving us into the next era of the risk-averse supply chain. In this era, decisions will no longer be made based on lowest cost alone. Supply chain folks will know that there are trade-offs in every decision. And in the risk-averse supply chain era, we will see a decreased emphasis on cost and an increasing emphasis on resiliency and service. In this new era, there will be losers and there will be winners. It's inevitable, and it's been coming for quite some time. According to Fortune, 94% of the Fortune 1000 are seeing coronavirus supply chain disruptions. That's staggering, but it's not the reason that we're moving into a risk-averse supply chain era. It is, however, the catalyst. Supply chain has been taking its seat at the table for the last decade as it becomes a center of differentiation for companies. Amazon used their supply chain to differentiate their business, and it forced other companies to change their supply chain to stay competitive. That meant quicker delivery, faster response, better customer service, a focus on last mile delivery, and just a ripple effect of other changes. These changes increase the stress on supply chains and supply chain teams. So companies are stressing their supply chains to become centers of differentiation, and at the same time, the number of risk events are increasing. According to the latest Resiliency annual event watch report, the number of global supply chain risk events increased 36% in 2018. You can see the trend here. Green is 2017 and blue is 2018. This is showing that COVID-19 should not be the sole reason that you look at your supply chain. There are other more common events adding risk to our supply chains, and they're happening more frequently. As leaders, we need to make sure that we understand how these events will impact our supply chains. If we're going to meet service objectives, maintain a profit, and minimize risk in the real world, we need to look at supply chains differently. Instead of making decisions based on lowest cost, we need to make data-driven decisions that weigh risk and service level along with cost. The companies that fail to look at their supply chain differently will fail, either because they can't maintain profits, can't respond to a risk event, or because they can't stay competitive. Companies that move from lowest cost to a risk-averse supply chain will win in both the short and long run. Another company that can win through this is Walmart. The event has had a significant impact on their supply chain, which no one could fully plan for prior. The companies that win will be the companies that can adapt because they consider cost, risk, and service when they plan their supply chain. When they emphasize resiliency, they can then build a playbook to respond to any event. There are three things that we know to be true. Supply chains are at center stage because they are a source of differentiation, and COVID-19 has shown that they will fail. Supply chains are getting more complex, and the number of supply chain risk events are increasing. So we know these three things, and we know how to manage each one individually. But what makes it challenging to manage when they're all happening together? It's because it's a complex system with interaction and variability happening over time. Let me repeat that. It's because it's a complex system with interaction and variability happening over time. Yet, as supply chain leaders, we're planning based off of an optimized happy path. In other words, we're planning for a perfect world. We don't plan for the real world. So my challenge for you is this: stop planning for the happy path. Rather than relying on historic information to plan and solve problems, you should establish systems that can anticipate real-world complexity. The perfect supply chain with your happy path is out there, and there's a way to find it. It's called optimization. We can use optimization across the supply chain. I'm sure you're familiar with network optimization, transportation optimization, warehouse optimization, slotting, etc. These tools find the perfect supply chain. They find your happy path. And don't get me wrong, optimization is incredibly important. You should know what your perfect supply chain looks like, but you also need to realize there's a gap between your perfect supply chain and the real world. That gap is caused by things like driver shortages and caps, raw material shortages, natural disasters, trade wars, transportation failures, weather, fires, pandemics, cyber attacks, strikes, recalls, and events don't just have to be negative. The real world has demand changes over time, which can create deviation from your happy path. So our challenge is to not just rely on the perfect supply chain design. We should know it, but if we want to win in the risk-averse era, we must capture real-world complexity and plan our supply chain for it. So I said we must capture real-world complexity and plan our supply chain for it. But what do I mean by capturing real-world complexity? This can be boiled down into a few simple components. Complex supply chain processes. One of the things that makes supply chains difficult is that they are complex. At a fundamental level, supply chains are a series of processes with a lot of system interaction. While you can map out a process relatively easily, it takes a sophisticated tool to capture the complex interactions. The way it's done is through technology called simulation. Variability. There's variability all across your supply chain. Sometimes it takes a day to ship, sometimes 2 days, and on occasion it might take a week or anything in between. We describe variability in your process through distributions. There's variability in production, shipping, suppliers, weather, costs, and a million other variations. When you include variability, you capture real-world complexity. And resource constraints. If you had unlimited resources, planning would actually be really easy. But of course, that's not the case. Your company has limitations on its resources, production capabilities, warehouses, warehouse space, trucks, people, cash, and so on. When you incorporate resource constraints, you capture real-world complexity. And risk. We talked about the gap between the perfect world and the real world. And one of the major differences are the risks and events that happen in the real world. And finally, change over time. Supply chains are constantly changing every minute, every week, every month, every year. We have to consider these changes if we want to capture real-world complexity. I've talked about each of these individually. When I say supply chain leaders now expect that we capture real-world complexity, I mean that our planning needs to take all of these things into consideration. We shouldn't plan for the happy path. We should plan for complex supply chain processes with variability all across the supply chain, limited by its resource constraints, impacted by random risk events, all changing over time. That last part is important to emphasize because when something changes in the supply chain, it has a ripple effect due to the complex interconnected processes. In the past, it was a struggle to consider the complex processes, variability, resource constraints, and risk over time. Companies were limited to spreadsheets and optimization tools as they strive towards their happy path. We are now living in a new era that requires us to capture real-world complexity. anyLogistix takes a unique approach to supply chain problems that is unlike anything else out there. It uses the world-leading anyLogic simulation engine to capture the real-world complexities and system interactions. It uses IBM Cplex for optimization to determine the perfect supply chain, the happy path, and it makes it easy to analyze the supply chain through scenario analysis. When you capture the real-world complexity of your supply chain with anyLogistix, you can optimize, simulate, and compare every scenario in a completely risk-free environment. This is important, so please let me repeat that. When you capture the real-world complexity of your supply chain with anyLogistix, you can optimize, simulate, and compare every scenario in a completely risk-free environment. The one takeaway that I want you to have after this webinar is that you need to make sure that you capture real-world complexity when you make decisions in your supply chain. Of course, it's easy to say, but how do you do it? The answer is that there's an innovative tool on the market that's unlike anything else out there. It's anyLogistix. I had a fun interaction with a supply chain expert after seeing ALX and used it for the first time. He said, there's something beautiful about how ALX brings optimization and simulation together and makes it easy to use. So imagine if you had to relive the outbreak scenario in China again. Alex Franco, Senior Supply Chain Consultant, is going to walk you through how you could solve a real-world supply chain problem. Take it away, Alex.
Yeah, thanks, John. Well, first of all, welcome everybody. I'm happy to hear that you're joined our webinar. The great thing about today's webinar is that we will be demonstrating a scenario. For those not familiar with anyLogistix, it's a supply chain design and solution analytical tool that performs the following components. GFA, it's a center of gravity that helps find the location for forward stocking locations or DCs, warehouses. Also network optimization, where you can find your optimal design to max profit. Simulation to support and provide insight into your supply chain performance and behavior. And finally, transportation optimization to optimize your transportation and provide milk runs to reduce transportation costs and maximize vehicle utilization. So for here, I'm going to show you guys this one scenario, give you a bit of a storyline. So in this particular supply chain distribution, it's a distributor of smartphones supplying over 200 customers, retail and or distributors located in the largest cities in the US, as you see. It is known that the largest supplier in the US, so this distribution company is not small, probably one of the biggest. And as you see, most of the cell phones, smartphones, are coming out of Asia, mostly out of China. And that's due to their low production cost. Now, as the event, one of the first things that China is going to do is obviously it's going to close its borders, and that stays away from happening March 1st, and that's due to the outbreak. So the need to understand if their backup factories in South Korea and Vietnam can handle the demand volumes is of high importance. If not, we would need to understand the impacts across all the areas of the business, from locations, suppliers, customers, smartphone models, and their components to identify what will be impacted. So let's take a look, deep dive into our map editor. Here you can easily see the Shanghai area in China, where most of the suppliers are in green. And here you're going to see how they provide all the actual components to make up their brands, the smartphones. Here there's 3 factories, each one create and produce a brand. One is your brand A, your brand B, and your brand C. And what they do is that when their finished goods are done, the smartphones are completed, they're sent, exported out through the port and sent back to the US, where they reach the US Port Long Beach and straight directly into distribution to fulfill all the demand across the US. Now, taking a look at Vietnam, similar fashion. Obviously, similar fashion where they have suppliers, but the only difference is that they only produce and their backups to Shanghai, and they only produce the A and the C brand of those phones. And in South Korea, they produce only the B brand smartphones. Perfect. So now that we understand a bit of the storyline, let's go ahead and check the events table. So let's take a quick dive at our events table. This table is used to essentially assess potential risk of upcoming events. And they include the probability of occurring. As you take a look on the right side, this column helps us to understand the probability of something happening. We know that the border will be closing, so that's 100% guaranteed. But this event table, you could add many events like a fire, an earthquake, a cyber attack, a strike, a natural event, even a man-made event to assess the risk. And many of these events can be made to impact the node, like a DC, shutting down a DC, a factory, a supplier, a warehouse, or impacting a path, a border, a country. And you could easily even decrease or increase the demand, even the production. Although this supply chain has several other risks, none is as significant as the closing of the border. But the great thing is that the expectation, it will reopen back up in 3 months, 90 days. So let's take a look at our products. So here you'll see the 5 main smartphones. As I mentioned, 3 brands. The first 2 handsets are the most popular phones in the US, and they're branded by the A brand. Then there's the B brand. The B brand obviously is made in China just like any other China, but for backup purposes, they're also being produced in South Korea. These are definitely the 3rd and 4th most popular handsets in the US. And then the 5th most popular is from the C brand. So this gives you a little bit of an idea of the demand of each one of these, from high to low. So although a simple smartphone in today's world could contain about 300 parts and components, in this scenario, what I've done is condensed it to a less complex BOM in order for everyone to follow. So we set it up to 3 parts: the body and components, the smart box and accessories, and the microprocessor. Now, in many smartphones, in today's world contain 2 of them. So we added a quantity of 2 for these. So now we're continuing to provide these components to make up one produced end product, which is our 5 models, our A1, A2, B1, B2, and C1. Now, many of you guys are asking, well, I don't work with BOMs. I work with finished goods. That's exactly the point I'm trying to get to. We could easily introduce another 100 models, or just introduce another finished goods such as food, prescription drugs, clothes, shoes, you name it. It can make it very difficult for anyone to analyze using a simple spreadsheet, as John mentioned in one of his slides. And in my opinion, it's holistically impossible to do so that way. And the only way to do it is in dynamic simulation. So a lot of people are asking, why is dynamic simulation important? Because it can take into account your optimization, your profit, your costs, from your supplier, from your production, your inventory, your rent, your utilities. And it also could take into account your service level. Now you're listening to the customer. How is it going to impact them? And you can lay it across a timeline to identify not only what, where, and when, but the why. It allows you to see into the future and determine how your supply chain will behave, providing insight for making the best choices today. It allows you to make those desired changes and be able to run it in a virtual simulation as a proof of concept before you implement it in the real world. And in today's age, that is phenomenal because it will end up saving you time and money. Who wouldn't pay for that? So let's start working with this problem. And let's create a risk assessment and of this issue in order to strategize and prioritize our next steps with our executive, sourcing, planning, and operations team. All hands on deck. Okay, so imagine you are in a war room with the team and you're being asked the following questions. Do we have anything to worry about? Will we run out of smartphones? Which models and when? I mean, we've all heard these questions. If several are impacted, which should we prioritize? What's the revenue impact of each? How many customers can we potentially lose? Will our backup factories keep up? Do they have the production rates to meet the demand? Are there any raw material shortages that prevents them to produce any of the smartphones? Are any raw materials from China that can impact any of those factories due to the closing of the border? Should I look for other potential suppliers to provide the specific components, or should we locate a finished goods supplier that can purchase the smartphones from in order to fulfill the demand of our customers? Potentially with little to no margin, is it worth it? So what I've actually done is I've actually run these solutions prior to our webinar because in the interest of saving time, each one of these could take about a minute to run. So I've gone ahead, run the models and the experiments to help us solve this problem. So let's take a look as if I ran a risk analysis experiment. Now, keep in mind, when we run a risk analysis experiment, we're running an iteration of 5 times the probability of all those events occurring. This way, it helps us understand if at one point we're going to fail and at one point do we recover. And this is important because it helps us understand what timeline where we need to do something specifically or not. And as mentioned, everybody's failure service rate is different. So that's something that every company and organization is going to work on to understand what is acceptable to them. What's an acceptable service level? So let's take a look at the results with our first initial run. And taking a look at our target service level first of all. So here are our smartphones. Here is the smartphone A1. As you notice, doing considerably well. Small impacts there, something that we could improve on, but there is a significant impact here when the border closes. As the border closes around 60 a day, you can see that eventually 2 months later, there's an impact. How significant? We're going to have to find out. So A1, we need to work on. A2, pretty good. Definitely, you can tell it's above the 93%, acceptable. B1, oh, major impact. As you see, right after the 68-day border close, maybe about 10, 15 days later, it hits bottom. Pretty much saying that we cannot provide any service or fulfill any of our demand. So this is something we should be looking at considerably. So the B1 looks like it's a priority. Here's our B2. No issue, perfect. And our C1 as well, no issue. So what we've done here is that we identified 2 potential problems, the smartphone A1 and the B1. Now A2 showed potential improvement, but it was not impacted by the border. And as I said, it was still above the 93% service level. So let's find out how significant of an impact this is. And what I mean by that is financially. So here's a quick graph to show that. So let's focus on the 2 big issues, the A1. As you take a look, here is the actual revenue of A1 handsets over time throughout the year. And as you take a look, here's a small plateau. Here is where something slowed down in our revenue. If they wouldn't have slowed down, this would have gone directly up to here. Just kind of eyeballing it, it looks like that's a 600 million impact loss of revenue. Let's go directly to our B1. As you see here, quite a significant impact. But is it really impactful? Let's find out. There we go. So it looks, just by kind of eyeballing, it looks about $150 million impact loss of revenue. Although it was a longer plateau, it's not a popular handset. So the impact on the A1 is much greater, even though the B1 looked like it was greater initially. So we would need to prioritize. It would be the smartphone A1 that we would need to look at first. All right, so now that we ran a risk analysis experiment to demonstrate the probability and the most likely of what would happen, we could also run a simulation to understand a little bit more detail. And in this simulation, we could also see the service level. In similar fashion, you can see the A1 drop way below 90% at one point, gradually, and then the B1 dropped dramatically. So let's find out what's potentially causing this. Now let's see if we could find it in our available inventory, including black backlog. All right. Okay, so let's see what we can find. Okay, here you go. So there is a bit of a situation with our smartphone B1 coming out of South Korean factory. As you notice, it starts taking a dip in the backlog, meaning that eventually there was nothing in the inventory and it started taking a backlog of its requests, of its orders coming from the US, DC. So it started taking this backlog and eventually just continues going down. So we've identified that that's a problem. Now we need to understand, is it a production problem? Is it a component missing problem? What is it? Here's the other situation. Just by looking at it, we have the microprocessor CMP. And it looks like it could be the main culprit. Obviously, just by looking at our BOM, we could easily address this as the missing component and the main issue on why the smartphone B1 is not being produced. There's nothing in inventory, and it's also being backlogged. And these two are related. Just let's see if we could go into our master planning section, product flow, and see if they're receiving any of that product. And if you take a look, most of the CMP components are actually going into the factory B. But as you see, there's none that are going into the factory in South Korea to make the B product. So this is a problem. It's not receiving any CMP supply. So obviously, this is definitely the main culprit. They are not receiving the product to actually create the finished good smartphone. All right, well, let's see if we could do something about it. Let's take a look at our actual sourcing table. So the reason why we're going to see if, let's just find out if there's potentially a supplier that can provide this. So let me go ahead and filter out supplier, CMP. Perfect. Okay. So now this tells me that the only active supplier that we have in our organization actually only comes from China. So there's nothing we can actually do because, well, we can't really get a quick win and find somebody. So we're going to have to see what we can do to solve this problem later down the road. So let's go back to our smartphone A1 then and find out if there's something we can do there. Let's find out what the problem is, first of all. Let's go back to our available inventory. Take a look at our backlog. Once again, let's search for them. Okay, You open that up. There you go. So that's the smartphone A1, but that's another problem. That's an over inventory. There we go. So here is the Factory A Vietnam Haiphong smartphone A1. And as you take a look, you can see that there is a problem there. So there is a backlog, meaning that it couldn't produce it fast enough. And so it continued backlog, and that's why it's taking a deep dive like this. And then most likely what happened is that they dropped the order to see if they could get it from somewhere else. So an obvious impact, definitely a production problem. It's just not fast enough to create what it used to in Shanghai. All right, so we have the smartphone A1 with the Vietnam factory production issue. And then we also have the smartphone B1 with a CMD microprocessor component sourcing issue to solve. Although the A1 will take priority due to the revenue, there is really no additional issues. There's just two. So we could decide to work on both at the same time. But in the real world, when you have 1,000 parts or 1,000 finished goods, that's typically not the case, and you're gonna have to prioritize. All right, so let's go back to the sourcing, to our storyline. Let's just say we wanna solve this problem. Let's just say that the sourcing department searches their list of suppliers for the missing microprocessor, the CMD, to find out if they can find a potential supplier in South Korea. And let's just say they do find one. And due to the quick visibility, the sourcing team was able to find a potential supplier and substitute in South Korea, which is great. So they find out there is one. So they immediately contact the supplier and potentially beating other competitors as well to the line. And they say they can have the shipment to us in a week. So that's great news. But let's find out what the impact would be. Should we use them? That's the question. All right, so let's solve this problem. Let's go ahead and let's go to my supplier table. What I'm gonna do is I'm gonna add that supplier. It's a new supplier, so I'm gonna go ahead, introduce them. There you go. They're right there on the map now. And we're gonna go ahead and make sure we connect to the factory. We need to let the factory know that they can source it from there. So let's go to our sourcing table. And let's filter out that the destination should be the South Korean factory. Perfect. And it's the CMP that we want. All right. So what we're going to do is, obviously, we're going to add the supplier in. Great. So now that we add the supplier in, we're going to change this because it has two opportunities. It can receive it from China and Korea. And well, currently it's only going to most likely get it from the new supplier. But once the border opens up, we're going to allow the simulation to choose either one. So let's choose something dynamic. Let's choose the cheapest. You know, most likely it's cheaper in China, so it's going to revert back to China once the border opens, which is fine. That's what we want. Okay, so let's look at our results. Well, first of all, in the interest of saving time, I'm not going to run it, but I have the solution already, so I'm going to go ahead and take a look at the results. Okay. So let's take a look at our target service level. Here's our A1. Obviously, it wasn't going to impact that one, but we knew it would potentially impact B1. And look at here, 100%. That's very good. So that tells us that the service level will be impacted 100%. As you remember, it was all the way down here. Now we got it at 100%. This is what we want. And the revenue, and let's take a look at our revenue graph. See what the impact there was financially. This is great. As you can see, the smartphone B1, it's a perfect revenue growth. That means no impact. That's great. We were able to salvage the B1. This is great news. So this is are one of our immediate issues, but it has not solved our major issue, which is smartphone A1. The great news is that the sourcing team has just learned that there's a distributor in Mexico, a warehouse, that has a large supply of smartphones, about 40,000 units. And they're willing to sell it to a higher price, though, of $400 per unit at an initial batch size of 5,000. And we cannot order anything less than five at a time, but they're allowing to let us order at increments of 2,500 after that. Okay, so the question is it worth it? How much product and how long will it cover us? So let's see if we should do it. So first of all, let's go ahead and add that one warehouse. There we go. Let's make them, let's add them. So now that I've added it, it's initially closed. Now I got to activate that warehouse during the second and third month. Why is that important? Because initially we didn't know that they existed. So we got to make them be existing on the second and third month. There you go. So here's the second month. I'm going to go ahead and activate that. And then I'm going to leave it toggled off for the 7th month. That once the border opens up, they're going to go away. We don't want them to be active no more. Now I'm going to go to the sourcing table and add the Mexico warehouse as a potential source now. Currently, it's not connected. So let's go ahead and do that. So let me filter the source or the delivery destination being the DC, CA, California. Here it is. And we're going to go ahead and add the Mexico warehouse. There we go. And now we're going to change from first fixed source to cheapest dynamic source. Once again, once that time is over, we want it to flip over to China as it's cheaper currently. And it's most likely cheaper because they Mexico received it, and they most likely took in transportation costs and other additional costs as well. All right, so let's go ahead and add a sales now. They're the ones selling it. Let's go ahead and introduce that. Perfect. Here you go. Let's add the warehouse. And they're selling smartphone A1 with an exact starting batch size exact of 5,000. They said that they would require a step size of 2,500. Okay. And they were going to sell it for $400 each unit. Perfect. Now let's include that inventory in the Mexico warehouse. And here you go. And we're going to add the initial stock. They said they had 40,000 available for us. And now we're also going to go into increase the inventory at our DC. And why is that important? Well, because they're receiving larger batch sizes. So we want to make space for it in our policy. So let's go ahead and do that. Here's a smartphone A1. And let's change that to from this to 10K. And obviously we could continue working on this to make it better and more resilient. Okay, and let's change the initial stock unit to 10,000. Great, that looks good. All right, so let's go ahead and take a look at the results. Let's see what happens now. And as mentioned, in the interest of saving time, I ran those results prior to the webinar. Let's take a look. All right. So let's first of all take a look at our service level. Take a look at our A1. Okay, so the first thing you notice that it did still take a dip, but it just went below the 90 part. So it didn't meet our standard service level. But let's see what kind of financial impact it made. obviously it did help it out. Here you go. Here's our profit, $1 billion. If we were to go back to how it was before, prior to the warehouse, here's our profit then, 967 million. That means we made $33 million adding the warehouse. It didn't completely solve the problem, but it helped reduce the risk and it kept customers and we made a profit. So 3 things to keep in mind. 1, we immediately knew that the 40,000 smartphone A1 units at the warehouse in Mexico would help curb the risk and potentially gave us a chance to seek yet another supplier or distributor before even the border closing. That's great news, because that could help us potentially get a few other ones before other competitors actually understand what's going on. 2, who knows if the Mexico warehouse would have had the inventory in a week or in a few days and at the same price. The price could have easily gone higher in a week or days if they knew there was a shortage out there. 3, we also realized by looking at the backlog at the DC, California, that we were able to capture that the inventory levels we need to be adjusted for the smartphone A1 for the company to be more resilient for future events. We saw that the smartphone A1 inventory was just a little bit too lean and potentially is the reason that the event easily impacted the company financially. So obviously the management definitely should be very happy because they gained quick visibility to the issues to identify the challenges, the impacts, and priority to solve their problems immediately upon and during the issue occurring. The simulation helped them effectively and efficiently make strategical and tactical decisions on the spot. Going forward, if they can predict with ample time any upcoming event, they will have the ability to provide a solution such as using a safety stock estimation experiment. The safety stock experiment is just another essential tool, part of ALX, to provide a prescriptive safety stock level by maintaining service levels to the company standard and helping them build further resiliency in their supply chain. But we will leave this topic for another upcoming webinar to cover. So ALX is a fantastic tool for your supply chain analysis. Now I'm going to hand it back to John so he can share with you how you can use ALX in your organization. Over to you, John.
Thank you, Alex. So let's review. We saw an event coming. In this case, it was the outbreak, but it could have been a fire, a strike, or any other event. So we used anyLogistix and we identified the issue. An event was disrupting the supply chain by closing a border. We then quantified the issue. We had 2 problems: production limitations in Vietnam and a supplier that could not deliver the components for a product due to the border closing. This would result in a loss of millions of dollars. We then prioritized the win. We focused on what we should solve first to minimize revenue loss. We adapted as a team. We created an action plan so our team could respond appropriately. We maintained our customers. We found a supplier and a manufacturer to allow us to meet our demand despite losing critical nodes in the supply chain. And finally, we won new customers because we adapted quickly and found alternative suppliers. We can service new customers when competitors will not. So whether you're faced with short-term events or building a resilient supply chain, you can use anyLogistix to make data-driven decisions. When you use anyLogistix, you'll make faster, smarter decisions, your business will win, and you will beat your competition. anyLogistix is an innovative, world-leading tool to help you capture real-world complexity in your supply chain, which is key to winning in the risk-averse era. If you want to work with anyLogistix, it's easy to do. Here's how. First, you should contact your local anyLogistix partner to start the conversation. You can find your regional partner at anyLogistix.com. If you are in North America, you can contact me at jsantavi@simwell.io. Second, you should join an anyLogistix training class. We are offering live virtual classes. And finally, anyLogistix is an incredibly easy tool to learn. So after our short class, you'll be ready to bring the software in-house and build a resilient supply chain ready for the risk-averse era. anyLogistix makes it easy and fast to capture real-world complexity to analyze your supply chain. If you want to work with anyLogistix in your company, you should start with a training class. We have a live virtual training class Tuesday through Friday next week. That's April 21 to 24. You can sign up for that class at anyLogistix.com. Go to resources and then training events, and you'll see a list of all of the events available. If your schedule is booked next week, we have another public class scheduled for the last week of May. You can sign up for it at anyLogistix.com. Again, go to resources and then training and events. And finally, if you have 3 or more people on your supply chain team, I highly recommend a private training class where you'll get more attention and focus on your projects. Simwell offers private, live, virtual training classes that we can schedule to fit your team's needs. You can contact me directly at jsantavy@simwell.io to schedule a private training class. One more thing, we are so thankful for you making the time to join us on our webinar that we are extending a discount if you sign up for one of our public training classes in April or May. Use the code SimwellWebinar20 to receive a 20% discount on every ticket that you purchase. This coupon will be live for the next 5 days. And if you like today's webinar and want regular tips on simulation, data science, and optimization, follow us on LinkedIn. And if you go there today, you'll find a new blog on building a resilient supply chain. So we had some great questions come in during the presentation, and I'm excited to answer them. I'm going to, we had a lot of questions on, let's see, what's the difference between optimization and simulation? So optimization is a pretty standard tool used in supply chain analytics, and simulation, it has been used for quite some time, but it isn't new to a lot of folks. So a good way to look at the difference between optimization and simulation is that optimization allows you to find that perfect supply chain design. It allows you to sort of take a snapshot of your supply chain and find the perfect design from it. Simulation allows you to capture the real world complexity of your supply chain and see how it will actually perform over time. So when you use those optimization and simulation together in anyLogistix, you're able to go much deeper in your analysis and understand how risk events will impact your supply chain. So another question here that I've got from a few different folks was around where do you find a good source for risk data? And another way is how you collect quality inputs for real world events. And that's a great question. So there's different types of events, of course. There are events that you do have historical data on. So for example, that might be there might be a fire season or a hurricane season that impacts your business or your supply chain. And if you have that data, great. You can put that into anyLogistix. You can also take a look at other types of risk events. So for example, a strike, and you might not know a strike is happening, but you know what's going to happen when the strike comes, which the facility is shut down. So then it's not so important what caused the event, but it's important that you analyze the supply chain with a node or with a facility shut down, whether that was a fire or a strike or what have you. It's important what happens after that. So even if you don't have perfect data for that unique risk event, or for the pandemic, for example, you can't plan for that. You can't quantify that in a risk per se, but you can analyze it with your supply chain by shutting down different nodes and analyzing how you would respond to that. We had some questions on, will we share the model file, and will we share the PowerPoint file? And yes, this week you should get a recording of the webinar with files in it. Julian asked, is the screen difficult to interpret? I think he was specifically asking about the dashboard screen, and I'll answer that just in general. anyLogistix is a fairly easy tool to use. we have a 3 or 4 day training class that once you take it, you'll be well off, running and replicating your supply chain in a virtual world and doing this analysis. Of course, you get better over time, but it really just takes a couple of days training to go off and run with the tool. The dashboards, there are, I won't say endless, but there are hundreds of different ways you can set up the dashboard to show what you need to show and help you do your analysis. So once you learn those, it wouldn't take very much time to do so. Just working on it in a project for a few hours, and you'll figure out how you want to show those and get strong with it. So it is not very difficult to learn the tool or to interpret the tables and the data and the dashboards that you put together. Another question that we had was around the relationship between anyLogic and anyLogistix. anyLogic is, I'd say the easiest way to think about it is anyLogic is an engineering tool, and anyLogistix is a end user tool. So if you look at a supply chain project, there are 3 phases there. You have to gather the data, build the model, and do analysis. anyLogistix removes that model building stage so that you just focus on gathering the data and doing the analysis. anyLogistix also incorporates the IBM Cplex, so you can do optimization. So that allows us to solve problems like greenfield analysis, network optimization, transportation optimization, and then we get into, we add in the anyLogic engine to it, so we can start doing our risk analysis, our inventory planning, our policies, master planning, and we can go deep in there. A question: can we sync the software with the dispatching system of a company? What data is useful to fetch from there? So you can connect the software to pretty much any system that you want to pull data from, and you can automate that into anyLogistix. And so this tool can be a strategic tool, or you can use it tactically to make those decisions and be a real digital twin of your supply chain, and pull the data out for what you're facing today, and run your scenarios, run your simulations, and make changes. In general, how long does it take to go live, including loading data for a large organization? That's a great question. So if you, again, I would suggest our training class, which is 3 to 4 days. And once you take the training class, you'll be comfortable with the tool, and then then you can start planning out your projects. So once you pick a project, you have to gather the data, and depending on your systems, that might take a day or 2 days. It might take a few weeks. It depends on your company and your team and how you pull that out. But once you have the data, it probably might take a couple days or a week or 2 weeks in the tool, and then you can start to do your analysis. Of course, it can be much longer, it could be much shorter, depending on a lot of things, but relatively quick to get this up and running. In comparison, we've been building simulation models of supply chains for a very long time now, and it used to take at least 2 or 3 or 4 months to build a simulation model of a supply chain, and it's never been easier since with anyLogistix, where we could cut months of time out of doing this type of work. A question: are there example cases available? Yes, absolutely. Go to anyLogistix.com, download anyLogistix. There's a big download button. Download the PLE version, and there is a huge library of models that you can get started with. Greenfield analysis, network optimization, master planning, transportation optimization, risk assessments, you name it. There are tons and tons of models in there that you can just load up and start working with. What was the promo code for the online training? I will send that here. Simwell Webinar 20. You'll receive an email sometime this week with a recording of the webinar, all of the files, and we'll make sure that discount code is in there. It'll be good until Tuesday of next week, and you can use it for our April training or the May training. Can you do simulations with forecasting, modeling, inventory modeling, reordering scenarios, back ordering, stockouts? Yes to all of those. Great question. Another great question. Can anyLogistix simulate a production shop floor environment, or would anyLogic be required for that? anyLogistix has what we call extensions. So we can model some basic production shop floor and see how that impacts the overall supply chain. But most likely, if you'd be looking at anyLogic, if you want to go in depth on the production floor and modeling that. Another question about data connections, the software connected WMS or ERP. The answer is yes. Was the simulation shown in the webinar a discrete event simulation? Yes, it was. Okay, so these were fantastic questions. I know I did not answer all of them. I will look at all those and try to respond to all of them after after we end the webinar via email. I appreciate everyone making time. Thank you so much. Now, once more, you can download anyLogistix and find your local partner at anyLogistix.com. That's also where you'll sign up for future webinars and training classes around the world. You can contact Simwell at www.simwell.io or email me directly at jsantavy@simwell.io. And I want to, on behalf of Alex, Simwell, anyLogistix, and I want to thank everyone for your time today, and we'll see you on the next webinar. Thank you, guys.